Hey, Jody here. This is another video on TIG welding aluminum. Let's dive in. Doing an 1/8 inch thick butt joint today, and I'm knocking a little chamfer on it. Not a very big one, just a little one with this Walter flap disc. Then I'm going to wipe it with acetone before I weld it. I don't usually chamfer something like this. You can punch through it. You can get full penetration on 1/8 inch thick without a chamfer. I'm just experimenting here and see if it goes better. So I'm getting tack welds on each end. And as I often do, I'm pushing just a little bit more rod in there than just the minimum that you might make on a stainless steel tack. And I find that helps for two reasons. Number one, aluminum tacks can be really weak because it just gives you a little something to light up on and to weld to without melting or curling that end away or blowing it away when you get there. So either you need to put it on some spacer plates or just give it like a 2-degree tweak here so that the penetration has somewhere to go. This is just a practice plate. Obviously you can't do that on live parts, but I'm just wanting to get it up off the table so that I don't smash that penetration dead against the table. It actually is sort of I mean, you could do that with a backing bar or something. It makes it a lot easier to get nice even penetration. You can just romp it, but that's not what I'm doing here. I'm trying to practice to watch that puddle, watch it sink and rise as I add rod, and that's the key to making sure you got good penetration. So watch it sink right here. Boom, there it goes. It sinks, it drops down, and then each time I push rod in there, it rises up, and you can see I'm moving my electrode up and down as well. That really helps me not to clean up a lot of electrodes. If you try to just hold a really tight arc like you might try to do on a lap joint or something to get metal to push down into the root of the joint, you'll wind up growing that puddle right up into the electrode sometimes if you're not careful. So now I'm heading toward the end of the joint, and this thing is pretty saturated with heat. Nowhere for the heat to go now, and so when I get to that last little bit, when I get to the last little bit of this joint, I'm going to have to back off my foot pedal. Now, you could also stop halfway through or 3/4 of the way through and let it cool a good bit, but right here I'm just leaving the rod in to help keep the puddle cool and backing way off on the foot pedal. And if that looks funny, I can come back and just do a couple of quick pulses and put ripples in it or whatever, but it did okay. Small pieces of aluminum like this, the heat just really gets soaked in there and saturated. So I've done better, I've done worse. I need some practice. So we're shooting for full penetration on that butt joint, but on a T joint you're not. You just want penetration into the root of the joint and not much more than that. Now this is my TIG Finger XL. Not only is it good for a heat resistant pad, but it's just good for a glide pad like this. I've got this piece set on a piece of aluminum because I don't like arcing off on aluminum onto steel, and my table's a little rusty here too, and sometimes that puts arc marks on pieces. Not that it would matter on this practice piece here, but it just helps me to glide along nice and evenly. I can make a whole run without stopping. You can see I'm looking through the cup here. And from this angle, it actually looks like I'm not penetrating into the root of that joint, but it sure looked like it was from my perspective. That is the goal. Flow metal into the root of the joint, not much more than that. I've done a lot of cut and etch tests on things like this to make sure that I am getting in there too, to make sure I'm seeing what I think I'm seeing. This just helps me slide along. I can make the whole run without stopping at all, and it's just one way of doing things. You can see that clear cup too is just really lighting everything up. As compared to using a pink cup, there's a big difference. It's like somebody dimmed the lights when you put the pink cup on. Pink cups are fine. I use them all the time, but I'm getting older. It's easier for me to see with using a clear cup like the Furic number 8 that I use for this. Now I use a 332 filler metal on this thing, 4943. That was not a typo. 4943 is a relatively new alloy. It's a lot like 4043, but it's got really good properties. And I'm going to link up to some videos I think you might be interested in, some past videos I've done on TIG welding aluminum. This one was using that CK machine, testing out the difference in 50 Hertz and 250 Hertz, and testing penetration or watching penetration very closely without changing the amperage. I showed the back side on this also, and you can see how that root or the penetration is forming there. It's like pushing through skin, and that's the aluminum oxide film that is on all aluminum that you have to contend with. This video is a 1G 063 thickness, that's 1.6 millimeter thickness test joint, again using a clear cup lights everything up, and you can if you're watching carefully, you can see that puddle sink and rise there too. And that's what you want to watch for to ensure you're getting penetration on an aluminum butt joint. This was done in a fixture that will allow argon backing, but I wasn't using any. I didn't have any hooked up. And this is part of one video that I'll link up to here. I just showed how the foot pedal kind of works. When you're first starting, maybe you're quarter or halfway, and then when you get to the middle of a joint, you're almost full pedal, and then when you get toward the end, to prevent just melting away, you start backing off 2 or 3 dips from the end. Maybe feed just a little bit more wire in there. This video, this is the aluminum drill. This is what I call the aluminum drill. It's just get a piece of scrap aluminum that's at least 1/8 of an inch thick. This is more like 3/16 or a quarter, and just run beads very intently. This is where to learn. I'm getting left hand practice, I'm getting right hand practice here. You can see that cup lighting the way for me big time. It really helps when you're I wear glasses and I also wear a cheater lens in my helmet, but this cup helps me as well. And this is just practice stacking beads. Now the way you get the goodie out of this is you start testing your AC balance settings, you test your frequency, you test how often you dip rod, test left hand versus right hand. You just get lots of practice for a little bit of metal. I still do it periodically just to shake the rust off if I haven't TIG welded aluminum in a while. Good practice. You can never get too much practice. Now this video is brought to you, as all my videos are, by my online store at weldmonger.com. Let me show a few featured products here. I have already showed a few of them. This is my TIG finger product, and for a job like this is building a tote tray out of aluminum tread plate. I wanted to run the whole way without stopping, as much as a whole rod would go, and that lets me do that. Also helps me glide over these little bumps on that tread plate. This is a steel job I did with that cup, just showing the stick out and that it gets really good coverage on DC. This is one of the more affordable clear cups out there. This is a clip from a recent video I did working with Mike Zanconato of Zanconato Custom Cycles, showing an aluminum bike weld using this clear cup and how you could kind of see through it to weld sometimes when you need to. 18 CFH with some pretty interesting amplitude settings. This is my signature product, TIG Finger and TIG Finger XL, and sometimes they are bundled up for a savings. Like right here you can see YouTube's Best of TIG DVD. That's just some of the best TIG welding videos I've done over the last few years, and you get a free TIG finger with it. There's also a bundle like this 4-pack of Furic 8 cups with the TIG finger for some savings, or you can just buy them alone by themselves. So whether you're tackling a project or you want to pass a test to get a raise or something like that, or even get your first TIG welding job, I think all these products can help you take your game to the next level. I appreciate you watching this video. Thanks for your support. We'll see you next time.